Anyway, thanks for coming. I appreciate you guys coming out for this. Trying something kind of new with this, using something called Poll EV. So you can see on the board there. If you feel like downloading the app and participating in the surveys, please feel free to do so. We'll be doing Q&A sessions using Poll EV. Feel free to shout out questions as we go along too. This is an open forum, but we're gonna give it a try. Slow internet connection, so we'll see how it goes. All right. So briefly, we have an hour, so we're gonna have to kind of compress time because we have a lot of subject matter to cover. We're gonna cover some of the cloud providers. We're gonna cover implementing real-time search. I'm gonna talk to you about how to secure data inside that search, and I'm gonna talk to you about a little bit about how to analyze that data. A little bit about me. I'm currently the Director of Engineering for Forcura. Forcura is a document workflow and secure communications platform for home health and hospice. I was the Director of Product Development for Home ASAP and Play. I've worked in Jacksonville for about the last 14 years, various locations, a couple of these guys here too. So in my background, I am very deeply involved with Microsoft technologies. That doesn't mean I'm a shill for Microsoft. I've always believed in using the right tool for the job. So we're actually going to talk about some open source technologies. A lot of this, because of my Microsoft background, might sound like I'm preferential to Microsoft, but I promise I'm not on their payroll. So like I mentioned before, like to see if we can get some active participation going on here. We're going to use Poll everywhere. So like I said, if you want to download it, you can download it and then enter pollev.com/MatthewMarty342. All right, so first, let's talk about cloud providers, or as everybody likes to say, your data on somebody else's computer. That's kind of what everybody says these days. The cloud, like it or not, I mean, it really is the future of computing. What it's really done is it's allowed small, medium, and large companies to easily migrate all of their existing infrastructure into a managed infrastructure that provides things like disaster recovery, online backups, replication, all manner of things that are basically you don't have to worry about anymore. So, first poll, does your company utilize cloud service provider? If so, which one and to what extent? I'll tell you a little bit about Forcura. Forcura is 100% based in AWS. It was something that I kind of inherited and fought against for a little while because I wasn't terribly familiar with AWS, coming from an Azure background. But I've quickly come to learn it and to love it. Cool, it's working. All right. I love when a plan comes together. All right, so that's cool. So a lot of you are using other providers or not utilizing cloud service. It's interesting. So let's talk about two of the secure cloud providers. I'm only going to talk about Amazon and Microsoft because they're the juggernauts in the industry, obviously. Just reading the quote from Fortune, Amazon Web Services and Microsoft continue to lead the pack when it comes to computing capacity for their public cloud services, according to Gartner. Skipping forward, it's a two-horse race with market pioneer Amazon running first while Microsoft continues with a strong push at second. There are a lot of other competitors out there: Google, IBM, Virtustream, Rackspace, DigitalOcean is another pretty good one. I'm only really going to talk about two because I could sit here and probably fill an entire session just talking about the balance between the different providers. So we're just going to talk about two of them for this session. Just out of curiosity, I know you probably have a mix of developers, analysts, and everything like that in here. Just curious as to what the general stack is that you guys typically use inside day-to-day basis. Kind of pick the top ones. All right, cool. We got some React and Node people in here. Who's our React guy? Or gal? Right there? You're it. All right. Singled you out. Overwhelmingly Microsoft. That's interesting. Something completely different. Exactly. It gets to F. Cool. So, all right, let's talk about Azure first of all. I like Azure quite a bit. It's come a long way since its early inception. Some of the pros, if you're in the Microsoft ecosystem, it integrates natively with Visual Studio, which is really nice. It has seamless integration with on-premise Active Directory, which is also very nice. For me, it had a more intuitive naming convention. Stuff like virtual machines are called virtual machines. They're not called EC2 instances. Code deployment strategies are called code deployment strategies. It's not called Elastic Beanstalk. So it's a little bit easier for somebody that's coming from a traditional infrastructure to kind of get involved in Azure. And it actually can be slightly cheaper. It edges out Amazon a little bit in certain instances. Amazon edges out AWS or Azure in certain instances. The nice part is they both publish all of their cost online, and they've got really good cost analysis tools. Some of the cons, licensing from Microsoft software can be cost prohibitive to small business. Obviously, Microsoft is very much an advocate for their own software. So they've had limited open source options, and they currently have zero support for Red Hat Linux, which is kind of a problem for people that want to use Red Hat Linux. Some of the Amazon Web Services pros and cons. I love what Amazon is doing. They're releasing new technologies. It seems like they do it almost every day. They have Elastic File System now. They have an Internet of Things. They have a mobile hub. They have push notifications that integrate seamlessly with Apple Push and Google, and it's really nice. And DynamoDB, for example, they come out with new stuff all the time that's really interesting and kind of fun to play with. One of the things and one of the reasons that we use Amazon exclusively is they are certified by the US government to meet all kinds of different credentials, including HIPAA, SOC 1 through 3. If you need PCI compliance, AWS has all of that, and they are the only one to be certified by the US government. It's kind of a big deal. And they have the largest global reach of all the cloud service providers across the world. So they've got 13 data centers. They're building 4 more currently, and there are 2 to 3 availability zones within each data center. What an availability zone is basically you can think of something as a large data center, and then they'll have A, B, and C, and so you can have some of your data on A, and some of it on B, and some of it on C, and it'll scale out that way. Couple of the cons, it does, if you're developing in Microsoft, it does require an extension to be installed in order to interact with most of the services. It's a little buggy. I've had some problems with it, but overall it's gotten a lot better. They've patched it recently, and you can kind of get a really nice at-a-glance view of your SQL Server instances, your S3 instances, and all those other things. And then the nomenclature of the products can be very confusing. They have a lot of things that make sense a little bit later on, and I have a kind of a side-by-side comparison, so you can see what that is. And then the other problem that we've had is that support tiers can be kind of cost prohibitive. It can be pretty expensive. If you want a certified AWS architect to help you design your infrastructure, they charge a premium for that. So side by side, this is what I was talking about with the nomenclature. An EC2 instance or Elastic Compute is basically just a virtual machine. RDS stands for Relational Data Store. RDS in the Amazon world is pretty agnostic as to what that relational data store is. It's just a relational data store, so it can be anything from Postgres to Oracle to Microsoft SQL, you name it. Microsoft, of course, calls that a SQL database. Elastic Beanstalk, basically it allows you to deploy load-balanced web applications with one single click. Microsoft side, they call it a load balancer. Elasticache, Redis caches. Do we have anybody that uses caching in web applications here? So using Redis or Memcached or Memcached, okay. So one of the things that's cool about Elasticache is you can actually use either one. You can use either Memcached or Redis if you want to. Microsoft has really been pushing Redis. I think they own it at this point. I'm not 100% sure of that. Amazon Web Services have S3, which is simple storage. It's basically just a basic file storage. Microsoft calls it a CDN, which it really technically is. AMIs are machine images. Azure has VM images. Amazon has SQS, which is simple queuing. Microsoft has a service bus. And then SNS, which is simple notification. These are notification hubs. So they all have basically the same thing. They just call it something different. Here's a chance to ask questions about cloud providers before we start digging into how we get our real-time search in there. Anybody have any questions? You can also just shout them out. I guess not. All right. So moving on to real-time search. In my experience in development for the last several years, nearly every major enterprise organization, even small organization, has some need for search of some kind. Whether you're searching through a product catalog, whether you're pulling up patient records, whether you're trying to do some kind of analysis and retrieve records, search is kind of ubiquitous now in almost all aspects of the industry. SQL Server attempted to do full text searching. It's not awful, but it seems like it was sort of a last minute thing. So what we're going to talk about is what I'm very familiar with and what I've been working with for about the last 3 years, which is Elasticsearch. And I'm pretty excited that I'm the only person in Code on the Beach talking about Elasticsearch right now. So let's get into Elasticsearch and how that can work and how that can help with your business. So it's really grown over about the last 5 years. Like I said, I've been working with it for about 3 years. It is open source. It's built on top of Lucene, which is a Java product. So it runs very well on Linux-based machines, but it also runs on Windows servers too. So you can take your pick with that. If you're familiar with Apache Solr, it's very similar to Apache Solr as well. It is a distributed full-text search engine with an HTTP web interface. So that's how you interact with it, essentially. It doesn't matter what programming language you're using. It doesn't matter what kind of environment you have. It's simple HTTP interactions with JSON document storage. So you can use JavaScript to access it if you wanted to, or typically do. I made a mistake on this. It's actually now, they actually have a version 5 alpha out. So, but it's actively developed and supported by the community. We'll get into the clusters, the nodes, the shards, and the replicas with a graphic because it's a little bit easier to explain how that works. But basically, Elasticsearch works extremely well with 3 nodes. So a cluster is a collection of nodes, essentially. 3 is kind of like where you want to be, and if you have a really large set of data, you can scale it out to 10, 100, however many you want. At my company, we have 2 clusters with 3 nodes in each cluster. Now, inside a node is a shard, and a shard is a single instance of Lucene. So Lucene is the horsepower that actually performs the search. And then there's a replica of that shard on a different machine. And so I'll explain about how that works a little bit later. By default, when you install it, it installs 5 primary shards and 5 replica shards. And it'll scale them out over your entire cluster. So if you lose one node, you have a replica shard that exists on one of those other 2 machines. So it's very, very reliable. Unlike a lot of document stores like Couchbase, which I love, it has schema-free document storage. So you're storing JSON documents essentially. So if you're coming from a database world where everything is tabular, you kind of have to rethink that a little bit because you want to turn these tabular objects into hierarchical objects at this point because that's way more efficient in terms of Elasticsearch. You can very, very well just take a flat data structure and put it into Elasticsearch, but you're not going to get the benefit of being able to do recursive searching and aggregates and all sorts of fun things. But it also does provide the ability to do type mappings as well. So if you wanted to do aggregates on integer types, you can say, hey, this index, this field in this JSON document is an integer, or it's a string, or it's a date, and you'll get a little bit more performance out of it. So the way that you interact with Elasticsearch is through something called Query DSL, and the DSL stands for Domain-Specific Language. There are all kinds of queries, and they have a huge help site that's dedicated solely to showing you how to interact with Elasticsearch using Query DSL. Essentially, you download whatever library you want to use, whatever your IDE is. If you're in Visual Studio, there's Nest or Plain Elastic. If you're a Java person, they have this thing called Transport Client that you can use. If you're a Node, it natively works with Node. Essentially what you're doing is you're just building a query out and then posting it to your Elasticsearch cluster, and then it will return the results. The results all come back as JSON. You can do aggregates. You can do Boolean queries, which says, I want to find everything where this particular thing is true. Date ranges, I want to find all customers who have had a purchase order within the last 30 days, aggregate on that. Stuff the UI developers really like is they've got fuzzy searches. So as you're typing, if you have a couple of typos, spell the name wrong or something, it'll still come back with relevant record results. Those are always kind of interesting. We did some demonstrations of that for Fanatics here in town and had people spelling football players' names wrong, 2-3 characters misspelled, and it would still come back with the most relevant results. Like I mentioned, there are a lot of various clients that you can use to integrate with it. And you can run queries directly against the REST interface. There's a plugin for it called Head that I really enjoy using, and you can use Postman. I'm sure almost everybody is familiar with Postman. It's just a plugin, so you just put the URL in there, put your query in there, and hit go, and your results come back. I mean, we have, I'll show you. So this is what the Head plugin kind of gives you an idea of. So what we have here are we have our nodes. So we name them after sports teams. So we've got Bearcat, Rocket, and Seahawk. Seahawk has a star by it because that's the master node. So that's the one that we interact with, and it handles all the balancing out of the work to Rocket and Bearcat. Each of these columns are indexes. So we have an activities index, and we have a directories index. So you can see in activities, we have a little over 5 million documents. It's taking up 1.3 gigs of space. In our directories, we have 345,000, and it's taking up 261 megs. These guys, the ones with the really bold outlines on them, those are your primary shards. The ones that have the light around them are your replica shards. So as you can see, there's a bold shard here, 1, and then there's a replica shard of 1 over here. So if this guy goes offline, it'll still be able to fully recover all of the data. So that's why a minimum of 3 is usually really good. I mean, you can, for test purposes, if you're just testing on your local machine, you can run a single node cluster just for playing with it. But in a production environment, you want a minimum of 3 nodes. So hosting, you have a couple of options now, which is kind of exciting. You can kind of see that Elastic is really coming into the mainstream when AWS, Azure, and DigitalOcean have native support for it now. You can go into AWS and start an Elasticsearch cluster, tell it how many nodes you want, and hit go, and it's live in about 10 minutes, and you can start interacting with it directly. Azure has something very similar. They have machine images that they're using, so you can stand up an Elasticsearch cluster within Azure fairly quickly. Same kind of deal with DigitalOcean. And Elastic itself, it's actually Elastic now. They don't like being called Elasticsearch. It's Elastic. But they launched a service called Found, which is a paid-for service. They have a free tier, so you can play around with it and see if you like it or not. But you can start it up. They'll give you a cluster. They'll give you 3 nodes, and they give you some of the basic plugins that you get with it. So you can get Kibana, you can get Logstash, and all that stuff kind of comes right out of the box. I played around with it a little bit. We determined for my company that it was cheaper for us to self-host it within Amazon. So we actually have 3 dedicated virtual machines that are hosting it. But Found is really good if you want to just get started and kind of cut your teeth on it and see if it's going to be something that you can build out on. So the SelfHosted Pros, obviously you get full control of the service. So you can start it, you can stop it, you can move it, whatever. It can be significantly less expensive. It doesn't require a lot of CPU on the machine. It does require a lot of RAM. Because it is a NoSQL style database, document storage, it's going to store everything in RAM. So you're going to want 32 gigs if you're really planning on doing a lot of work, minimum. Let's see. And like I mentioned before, there's a wide selection of hosts available. Some of the cons, if you're doing it yourself, you've got to secure it yourself if you're using secure data. Even if you're not using secure data, it has a publicly available HTTP interface. You don't want anybody just going in there and playing around with it. So either you need to get that inside of your VPN. We'll talk about that a little bit more in a minute. It does require pretty intimate knowledge of the operating system that you're installing it on. Some variables have to be set. Java home. There's some memory items that need to be set on the JVM. You got to create your own backup and disaster recovery strategy, and you've got to create your own patching strategy. So Elastic comes out with a new version. Now you got to patch to 3 machines. No downtime. How are you going to do that? With a hosted service, they just do it for you. So if you're paying for it, you get backups, you get images, configuration steps, all done automatically. It's all done out of the box. You can do in-transit security, SSL security, and it's fully handled by the provider. So interacting with it, you're already encrypting your data, which is great. Nodes can be configured to load balance, scale, out-of-the-box configurations. You can just do whatever you want to with it. And it can be configured to update with new releases, which is great. Some of the paid hosting cons, you're not going to have access to the whole plugin ecosystem. And one of the things that makes Elasticsearch great is there is a huge amount of plugins available for it. Everything from the head plugin that I just showed you that gives you kind of a good overview, different querying mechanisms, all these things. It's like any other product that's on the market right now. Plugins are kind of the thing. So, and then if you're having protected data being stored and transferred back and forth, you may have to sign and execute a BAA, which is kind of a legal thing that says, they're responsible for that secure data. And again, with the paid hosting, you never really own your data. Somebody else owns it, so you have to trust them with it. So a lot of the questions that I always get are, how do you get data from a relational data store or some other data store into Elasticsearch? So my experience has been getting it from Microsoft SQL Server, because that's usually what we have worked on. If you're using Microsoft SQL Server, you can use triggers or a service broker. That's what we're doing. So anytime a table gets updated or a row gets inserted, deleted, or updated, we push a message into our queue, and then Elasticsearch updates that particular record. That does make it an eventually consistent model. And what eventually consistent model means is that if you make a change and you're using your database as your source of data, it's going to take a second or two to get up to Elasticsearch and get balanced out. So if you're trying to use Elasticsearch as a real-time sort of solution with a back-end database, it can be a little complicated from a UI standpoint. So imagine you go in, you delete a record, it deletes it out of the database. The database says, hey, delete this out of Elasticsearch. It does, but by the time the user is going back to their grid view of whatever those records were, it might still be there, right? Because it hasn't updated yet. So just kind of keep that in mind. They do have plugins available for both .NET and Java, probably others too that I'm not familiar with, that will stream the data directly from your database server. It takes a lot of the need-to-know kind of stuff out. So if you put this plug in, it just sits there and monitors your database for changes. I'm assuming it does a lot of the same kind of stuff under the hood, but if you're not comfortable writing a synchronizer and doing all of your database synchronization, then the plugins work pretty well. And then, like I said at the bottom, you'll probably have to write some level of code to get that to make sure that data gets in there. I don't know if this is going to play. Hey, there I am. So I was able to get to San Francisco this year in February for Elasticon, which is a lot of fun. It's very cool. If you haven't been, I recommend going. It's a great time. They really put on quite a show. It was my first time in San Francisco. But I had talked with some of the folks from Elastic before, and we were one of the early adopters in healthcare space. And so they were really interested to see what we were using Elasticsearch for. So they shot a little video of this, and I'll see if this will play. No, it's not going to play. Well, anyway, at the time we were bringing data, unstructured data from documents. So we received tons of documents via fax, and we scanned them in, and then we would OCR them using a library called Tesseract, and then push them into Elasticsearch cluster as completely unstructured data, and then use Elasticsearch to mine that data for, what are the top 10 most prescribed drugs from these lists? What are the top 10 ailments that people suffer from, diseases that people suffer from, and demographics, male versus female, all those things. So it's actually really interesting to be able to get all that data in there. We're still kind of passively doing that on the background. We're not really sure exactly what to do with it yet, but that was kind of our most recent implementation there. All right, so let's move on to securing Elasticsearch.
Ask one question.
Yeah.
What you said you're using AWS. What are you using to like provision the servers? Are you using like Chef or anything like that for kind of doing the spinning of your servers, or just going in and clicking the buttons in AWS?
That's a good question. So the question was, how are we provisioning our servers? And we actually have an Amazon machine image that we have set with Elasticsearch already installed, plugins already installed, everything's pre-configured. So if we ever need another cluster, another node, or one of them fails, we just simply select the instance size, attach the machine image, and it comes up online by itself. So all the security and everything is already built in because we have all these plugins installed. We kind of got it just right, and then took a snapshot of it, and then put a bash shell script in there so that when it comes online, it downloads the plugins and it does all its work. So probably something that could be done differently via Docker or something along those lines, but that's how we're doing it. Yes?
So I have like 10 different kinds of sets of data. I have YouTube videos, forums, website data, just all kinds of different data. Would I have to write some special app that goes out to all of them and puts it into Elasticsearch, or what would you recommend for that?
Yeah. So the question was, how do you get sort of distributed sources of data into Elasticsearch? You would need to write some sort of an application that would go out, pull the data down, and then put it into the index however you'd like it. Yep, good question. All right.
It's not hard, by the way. It's pretty easy. Just post. It's an HTTP. You can just post.
Yeah, it's a get and then a post. So it's actually pretty quick. So. Okay, so the kind of the meat of this conversation, we've got about 15 minutes left. So securing it. Obviously, that's something that's very important to us working in the healthcare space. It seems like every day we hear about a breach. Somebody's gotten in and done a giant data dump, put it on paste bin, social security numbers, and all those sorts of things. So if Elastic has an HTTP interface, how do you secure your data behind the scenes? Okay. So there are a couple of best practices. The first practice is to ensure that all of your data and log disks are encrypted. So when you're standing up a new Elasticsearch instance, when you're standing up that machine, before you even install Elasticsearch, make sure that your disk, you have whatever your disk is that's on there, has encryption on it. Once you install Elasticsearch, you can set data paths and log paths to point wherever you want to. So if you even want it stored on a separate disk, which I recommend, you can have it point to that disk. Use a firewall or IP tables to shield your Elastic server from the public internet. So we have ours hosted within our VPC. Only computers that are inside the VPC can access it. We have a single bastion server on our VPC, so it's virtually impossible to get inside. Never say impossible, but it's very, very difficult to get inside. And then we have basically what equates to IP tables. So the three servers are allowed to talk to each other, and the web application is allowed to talk to the three servers, and that's it. So everything is limited out. And then last but not least, per HIPAA and PCI compliance and a lot of other compliance programs, protected health information, protected data has to be encrypted in transit and at rest. So we've got that at rest part set with the encrypted logs and encrypted disks. There are a few options to convert your HTTP interface to use SSL. One way, and what we're using actually out of the box right now is something called Nginx, and it's an open source reverse proxy. There's a plugin for it. You just install it, and it basically it replaces the built-in web server for all intents and purposes with Nginx, and then you're able to you apply your SSL certificate, and you're good to go. There's another one called Jetty that you can configure. Again, very similar. It replaces the built-in Netty web server inside of Elasticsearch, and you provide your certificate, and your data is now encrypted. And then last but not least, Elastic, of course. Promise I'm not shilling for them. They have a service called Shield. It's a paid service, but out of the box, you get Elasticsearch, totally encrypted, SSL, TLS 1.2, and they're certified to meet or exceed HIPAA, PCI, FISMA, ISO, and SOC 1 through 3. So if you really want to protect your data, Shield's probably the way to go.
So when I hit that REST service, I can authenticate to it, right? It's some sort of password protected. It's not just public. Everybody can access it before I configure all of this.
Out of the box, it is public.
Okay.
Yep. When you install it, it is completely public, unless you've installed it inside of your VPC or something along those lines. But it's essentially it is public until you begin to lock it down. Now you can also, there are plugins for basic HTTP authentication, so you just provide a username and password and it connects. The way that we've approached it is we've kind of hidden everything out of sight, and then we have a service broker in the middle. And the web applications and services call that service broker, and it's the only thing that interacts with Elasticsearch through SSL. It's a good question. Okay. Do we have any questions about data security? Nobody? All right, cool. All right, 12 minutes left. We're doing good here. So analyzing your data. So now you have your Elasticsearch cluster hosted in the cloud. You've got your data in there. Now what are you going to do with it? So one of the things that I highly recommend checking out is Kibana. It started off early. It was part of the Elk stack, which is Elastic, Logstash, and Kibana. Logstash is exactly what it sounds like. Everybody has logs, and so Logstash is a very simple repository for getting your logs in there. And then Kibana is a web UI that goes over the top of it that allows you to actually analyze that data. Is anybody familiar with Tableau here? Okay. Kibana is like a poor man's Tableau. It gives you the ability to slice and dice your data, provide really cool visual dashboards, and the nice part is it's actually free. It's very easy to configure. And it'll run on any platform. You can install it on Windows, Linux, even Mac OS. So I'll give you an example of a little Kibana dashboard. So they look pretty cool. So you have your document counts, your last user ID, you got your timestamps on your hour of day, so you can see when the most logs come in. So this is just your dashboard, and then if you're really going to get into it, you click on Discover, and that's where you actually start building out your Elasticsearch queries, and it's like a visual query builder that you can drag fields over and look at time ranges and things like that. So it can pretty much provide any level of detail in your data. You can, if you're logging IP addresses, you can do it by IP address, requests, time of day, that sort of thing. The second one, okay, so they've got a free demo. So if you're interested in playing with it and seeing how it works, you can go to demo.elastic.co, and they've got a really cool Kibana set up there, and you can do everything without having to set it up yourself. Personally, I like to build my own custom visuals because there are a lot of business requirements that come in that the Kibana is maybe too much for. Maybe they just want 3 charts. So if you're into UI development, I strongly recommend using Highcharts. It's free. It's got a little watermark on it, or you can get the paid version that removes the watermark. But HTML5 embeds right in the web pages. You just drop the library in there, and then you interact with your service broker, your Elasticsearch cluster. It comes back as JSON, and you just bind it to the Highchart, and you get everything you want from bar graphs, line charts, splines, area splines, donuts. It's pretty cool. So. Seems to be working. All right. So conclusion. Let's summarize everything. My recommendations, having worked with Elasticsearch in the cloud for the last few years, I think cloud providers are great. I think they've really come a long way. I was skeptical at first, like everybody else, because I liked running my own infrastructure. But I think that they've come a really long way, and I think that if you're a small business and you want to get started, you can ramp up almost immediately and have an enterprise class infrastructure for very low cost. Elasticsearch, if you are in need of search, Elasticsearch is free. It's very cutting edge software. It continues to advance and develop. It has probably more stuff than you can even really dive into. Everything from MapReduce queries to JavaScript coming back on your queries, aggregates of aggregates, so nested aggregation, which is really neat. It's just very, very capable, and it's extremely high performance. If you're a beginner and you just want to get started, Elastic.co has a really, really great help site. They've got examples using curl, which you can paste right into Postman and go from there. At a minimum, you need to make sure that your data is encrypted in transit and rest. I think it's a good practice even if you're not hosting sensitive data. Almost all the queries now going back and forth through Google are all encrypted using HTTPS. So I think it's really important and a must if you're handling sensitive information. And then Kibana, again, outstanding tool to help you explore, visualize, and analyze that data in near real time. So yeah, and it's pretty cool because it makes sense. Developing Elasticsearch, using your tool of choice, you're able to glean what you need out of those searches, while at the same time, your C-level executives who want to see a cool dashboard and want to just want a summary, they don't need to know anything about the nuts and bolts, you can set those things up very, very quickly. So, and that's it for me, guys. So let's open up to some questions.
So do you actually have your executives log into Kibana directly, or are you taking it and sort of making it to a different page for them?
Good question. So she wanted to know if the executives are logging into it directly. We actually have a very large television in our office, and the Kibana Dashboard is right there. So it's an open floor plan, so anybody can see what's going on at any given time. Good question.
What's the most complicated query you're doing on your data, or the most complicated thing for analytics and stuff?
It's a good question. So the most complicated thing that we're doing inside, we have a lot of aggregations. They're just called ags in Elasticsearch. And so we have probably 3 levels of nesting on the aggregations. That took me a couple of weeks just to write the query. But the cool part is once you've got it, you just save it and then you're done. And then if you need something similar to that, you just kind of tweak it a little bit. And so you can, there are kind of 2 approaches that you can use. Sometimes I will just save the JSON file to like the local web server, like a protected folder, and then I'll just have it open that file and just execute it against Elasticsearch. Or you can use one of the plugins like Plain Elastic or Nest that allows you to actually build your query all the way down using like Lambda syntax, which is kind of neat. And then you can see your query, it'll beautify it for you and format it all pretty, test it on Postman, and then see what your results are. So they're kind of 2 approaches. Good question. Yes?
Have you saved a lot of money by implementing Elasticsearch?
Have we saved a lot of money by implementing Elasticsearch? From our standpoint, that's really difficult to quantify. Ours is more built around user experience. So we have a web application that our clients log into and use. It replaced a previous web application that was built on EXT.js. The new one is a MVC style application, and we've increased performance by probably 300 or 400%. So we haven't seen a cost savings, but our clients have certainly seen a cost savings because their job is workflow. And the faster they can get those results, the faster they can send documents out, get them back in, sign them, that sort of thing, they save money on the bottom line. So implementing Elasticsearch has helped our customers really save money more than us.
Are you aware if you're able to get like paid support for like if you wanted to run Elasticsearch on-prem and your company needs paid support? Is that like an option from anywhere?
Yep, absolutely. You can get it directly from Elastic. They have several different tiers of support. So even if you're running your own cluster, they can still sell you support. So if you've got questions or you get lost or need some assistance, and they're really good. TJ, who's one of their sales reps over there, who I know pretty well. You know TJ Lucia? Yeah. He's a persistent little guy, isn't he? Yeah. They gave us kind of a free insight, a free trial to do some analysis of what our cluster looked like and if there was any tuning that we could do. And I would say, top notch. We ended up not going with the support, but they do a very good job. Good question.
Are there any competitors to Elastic that are worth at least checking out?
Elasticsearch is a NoSQL database, document storage database. Apache Solr is kind of a competitor that's really more in the Java space, whereas Elastic is a little bit more platform agnostic. Couchbase has a lot of search functionality that they're putting in. You can do MapReduce queries inside of Couchbase right now too. But I still think that Elasticsearch is really the #1 search tool in the space right now.
Built on Lucene, you get all the goodies of Lucene? Okay.
All the way down, yep. It is built entirely off of Lucene. In fact, the founders of Elasticsearch worked on the Lucene project, so they had very intimate knowledge of all of that stuff and just brought it over. And so yeah, you get, like I mentioned, you get 1 Lucene instance per shard, 5 shards, 5 replica shards. So I don't think I've ever seen an Elasticsearch query, even a complex query, take more than about 20 to 30 milliseconds to execute. So, good question. Anybody else? All right, cool. Well, thank you guys for attending. I appreciate it. If you have any other questions that I didn't answer, please feel free to come up and see me after the seminar. But thanks again for coming out, and enjoy the beach.